Let's go to page 257 and let's start with number 402. Okay, so you have a g of x equal to 2 over 2 plus x over 2 minus 2 over 2 plus x. And it asks what value of x must be excluded from the domain of this function. Well, right off the bat, we can see that x cannot equal to -2 because of that. Okay, so that must be excluded. Next, let's go and simplify this over here. So let's make this into common denominator. So it'd be 4 plus 2x minus 2 over 2 plus x. And this becomes 2 over 2 plus x over 2x plus 2 over 2 plus x. Okay, now you are complex fractions, so multiply both the top and the bottom by 2 plus x. So that it cancels with the denominator. So g of x will becomes 2 over 2x plus 2. And you can factor out the 2 or you can divide it by 2. So let's go and do the factoring. And this will cancel out. So g of x equal to 1 over x plus 1. And so from here you can see that the x cannot equal to -1. Okay, so excluded value would be -1 and -2. Okay, so those are excluded values. Okay, let's go to the next one. Okay, so you have f of x is equal to 2x squared minus 3x plus 1. And you're looking for f of 4x. Okay, so again, whenever you see the x, you replace with the 4x. Okay, so this becomes 2 times 4x squared minus 3 times 4x plus 1. So again, all you have to do is just matching. So whenever you see the x, whenever you see this, they will have to match. Okay, they have to match. So f of 4x will equal to 32x squared minus 12x plus 1. Okay, and that's it. Okay, let's go to 404. So it says if f of x plus 1 equal to x squared plus 3x plus 5. You're looking for f of x. Okay, so we want to find if we want to find the x, f of x, we need to minus 1 from here. So you're going to have x plus 1 minus 1. Okay, and therefore, whenever you see x, you have to minus 1. So this becomes x minus 1 squared plus 3 times x minus 1 plus 5. So this becomes x of x. So you simplify, you get x squared minus 2x plus 1 plus 3x minus 3 plus 5. So f of x will equal to x squared. So that's going to combine the like terms. So this would be plus x, and the number would be 3. Okay, and so that's it. Okay, let's go to 405. So you have f of 4x plus 3 is equal to 2x plus 1. You want to find f of negative 9. So to find f of negative 9, what you do, you set this equal to negative 9. So 4x plus 3 will equal to 2x equal to 9, equal to negative 9. Okay, so set that equal to, so again, you want to see what the relationship between the two. And so from here, you need to go ahead and minus 3 on each side. So 4x equal to negative 12, and divide by 4, so x equal to negative 3. Okay. So x equal to negative, so you need to set x equal to negative 3. So in other words, you're going to have negative 3 plus 3. Okay, and so you set x equal to 3, negative 3. And so this becomes f of negative 9 will equal to negative 5. Okay, let's go to 406. So yeah, absolute value of x squared minus 6x equal to 9. So how many solutions are there in this equation? Okay, when you have absolute value, okay, first you need to isolate the absolute value, and after you go and separate into two equations. So you got x squared minus 6x equal to 9. So this is a positive equation, or the negative equation where x squared minus 6 equal to the negative on this side, so negative 9. Okay, then from here you can go and solve. So minus 9 on each side. You got x squared minus 6x minus 9 equal to 0. And from here you can solve by quadratic formula. So x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So x will equal to 6 plus or minus square root of 36 plus 36 over 2. So x will equal to 6 plus or minus 6 square root of 2 over 2. So x will equal to 3 plus or minus 3 square root of 2. Okay. And from here, you plus 9 on both sides. So you got x squared minus 6x plus 9 equal to 0. And this becomes x minus 3 squared equal to 0. So x equal to 3. So you got two answers here, one answer here. So there are three possible solutions. Okay. So you can two answers from here, one from here. So you got total 3 answers. Okay, let's go to 407. Okay, so you have the greatest integer function, and you also have the fractional part of the fractional function. And so you're looking for the greatest integer part z. So you got z equal to the base square root of 3 square minus 2 times square root of 2 square and over square root of 3 minus 2 square root of 2. Okay. Now the 2 kind of complicate things. Without the 2, without this 2, we can do the factoring into conjugates and it will cross out. But because with the 2, then it's no longer the difference of square, so we cannot do that. So we kind of have to just work it through. So let's apply the definition. So this one, this is a fractional part would be equal to this. So z will equal to square root of 3 minus 1, right? Because this is 1.7. So 1.7, the floor function will give you 1, right? 1.7. And square root of 2, again, the square root of 2 is 1.4. So the floor function or the greatest integer function will equal to 1. Okay, and on the bottom, you get square root of 3 minus 1 minus 2 times square root of 2 minus 1. Okay. Okay, so now you just have to work it out. So z equal to, so the work out you get 3 minus 2 square root of 3 plus 1 minus 2 times 2 minus 2 square root of 2 plus 1. And on the bottom, you can kind of just, okay, you can also simplify minus 2 square root of 2 plus 2. You can just simple algebra. Okay, so that's going to work out more. So this one will give you 4 minus 2 square root of 3. This one will be minus 4 plus 4 square root of 2 minus 2. On the bottom, this can combine. So you have square root of 3 minus 2 square root of 2 plus 1. Okay, so this and this cancel out. Okay, so we end up with negative 2 square root of 3 plus 4 square root of 2, 4 square root of 2 minus 2 over square root of 3 minus 2 square root of 2 plus 1. Okay, so what we're going to do is we need to go and factor the negative 2. So we end up with square root of 3 minus 2 square root of 2 plus 1 over square root of 3 minus 2 square root of 2 plus 1. And so this will cancel. So z equal to negative 2. So therefore the greatest integer of z will also equal to negative 2. Okay, let's go to 408. Okay, so you have the piece function. So f of x equal to x plus 2 if 3 is a divisor of the greatest or the greatest integer function x. Okay, and x minus 1 otherwise. And so you're looking for f of f of f of, so there are 2, 4, 5. Okay, so again, you have to work these things out. So f of pi, okay, this will end up with pi plus 2 because 3 is a divisor of the greater integer of this. So you have to use this function. The first one, you have to use this one. So you can line things up. So this becomes x plus 2, or pi plus 2. Okay. And so now this is no longer true for that, so you have to use this one. So you have to minus 1. So this becomes f of f of f of, this becomes pi. So you have to minus 1 to become plus 1. And then again, it's no longer true, so it becomes minus 1 again. So this becomes pi. And now it jump back to this again, so it becomes f of pi plus 2. Okay, and f pi plus, you have to use this one, so it becomes pi. So you have to minus 1, so pi plus 1. Okay, and that's it. So you kind of have to do it step by step. Okay. Okay, let's go to the next one. Okay, so you solve for the absolute value of 3y plus 7 equal to absolute value of 2y minus 1. Okay, now when you have a absolute value equal to absolute value, we can just go and square both sides. Now you only do that if you have an absolute value equal to absolute value. Okay, if you have something else, when you square, it's going to become messy. So in this case, you have one absolute value here, one absolute value. So in this case, this would be example if you want to square both sides. Okay, so when you square both sides, then the absolute value will be gone. Okay, because what happens is when you square, the reason for squaring is because it doesn't matter if this is positive or negative. When you square, it becomes positive. When you square, this becomes positive. So you don't have to deal with all different cases. Okay, so you square, you're going to get 9y squared plus 42y plus 49 equal to 4y squared minus 4y plus 1. Okay, so I'm going to move everything to this side. So you got 5y squared plus 46y plus 48 equal to 0. Okay, so that's going to do the factoring. So get your master product. So you got 46, and you have to multiply this. So you get 240. Okay, so you start with 1, 240, 2 comma 120, 3 comma 80, 4 comma 60, 5 comma 48, 6 comma 40. Okay, so this is it. So this would be the inside, so it'll be plus 8, and this would be the outside, so it'll be plus 6. So from here you go and solve. So you got y equal to negative 8, and from here y equal to negative 6 over 5. Okay, let's go to the next one. Okay, for this one, for 410, you're looking for area of the region bounded by the system. So you got y is greater than or equal to absolute value of x. And you got y is less than or equal to negative x plus 1 plus 4. Okay, so let's go and graph this. Okay, so y is greater than x. So what you do again? First, you graph as if it were a regular function. So if you graph y equal to x, okay, you get this situation, and absolute value will flip it over. So you end up with this situation. Okay, and then to do the testing value, you use any point that is not on the line. So I'm going to use 0, 1 as a testing point. So substitute into here. So you got 1 greater than or equal to absolute value of 0. So that's true. So that means you shade in this part over here. Okay? Okay, so let's go ahead and darken the line. Now next one over here, to graph this one. So again, if you just start with, okay, so you start with y equal to x plus 1. Okay, so that is going to be right over here. Okay. And you take the absolute value, means you have to flip this over. Okay, so it becomes like this. So that is this part over here. Okay, that is this part over here. Then it's negative, so you have to flip everything upside down. Okay, so it becomes like this. So that is this part right over here. Then you have to plus 4, so you have to go up 1, 2, 3, 4. Okay, so that's your graph right over here. Okay, so you're looking for this region over here. Okay, so you can kind of see the size. So notice from here to here, it's 1, 2, 3, and this is 45, 45. So this would be 3 divided by square root of 2. Okay, and this side over here is 1, 2, 3, 4, 5. So this would be 5 divided by square root of 2. Okay, so you can all these are 45, 45 triangle over here. So the area bounded by this, so k will equal to the length times width, so it'll be 5 over square root of 2 times 3 over square root of 2. So k will equal to 15 over 2. Okay. Okay, let's go to 411. Okay, from the coordinate of the points intersection of the graph of the equation, you have y equal to absolute value of 2x minus 2, and you have y equal to negative absolute value of 2x plus 2. Okay, so first let's go and isolate the square root. So you got y plus 2 equal to absolute value of 2x. Okay. And this side, if you move this over, so minus 2, minus 2. So you got y minus 2 equal to negative absolute value of 2x times by negative 1. So you got negative y plus 2 equal to absolute value of 2x. Okay, so notice that we isolate the square root of 2x, and it's kind of nice because both are square root of 2x, so we can set it equal to each other. Okay, so you got y plus 2 equal to negative y plus 2. So plus y on both sides and minus 2 on both sides. So you got 2y equal to 0. Divide by 2, divide by 2. So you got y equal to 0. Once you got y equal to 0, okay, you can come back to okay, you can go back to one of the equation. Let's go and use this one over here. So y equal to absolute value of 2x minus 2. So you got so you got 0 equal to absolute value of 2x minus 2. And you got plus 2 on both sides. And I'm going to switch. So you got absolute value of 2x equal to 2. And then from here you can go and separate into two equations. Again, the key is to isolate the square root. So you got 2x equal to 2 or 2x equal to negative 2. And you can solve by divide by 2. So you get x equal to 1 or x equal to negative 1. So you got two possible answers. You got 1 comma 0 because y equal to 0 or negative 1 comma 0. Okay. Okay, let's go to next one. Okay, it says, find the equation of whose graph is shown on the right. Okay, notice that this is symmetrical with x and y, okay, and it's bending, so it has to do with both absolute value of x and y. Okay, so you start with this, and just by trial and error, notice that the intercepts are 4 and 6, right? Okay, so you need to go and get 4 and 6. Okay. And if again by just plugging the numbers, this will equal to 24. And so divide by 2, so you're going to get 2 absolute value of x plus 3 absolute value of y equal to 12. Okay. again, the way to do that is just first you go and start with this one here. Okay, just focus on this one here. So you got 4 here and you got 6 over here, right? So in this case, you're going to see that that 4x plus 6y equal to 24. Okay, and by doing a reflection over the x and over the y, you just put absolute value. Okay, so that's where this came from. So again, start with the first quadrant part to get your basic equation. And from there, when you're doing the flipping, okay, that's when your absolute value over the x, and flip this way, you get absolute value of y. And that's how you end up with this equation. And you divide by 2 and you get that. Okay, let's go to page 258 and number 413. So you want to prove that the floor function plus the floor function of 2y greater than or equal to x, or the floor function of y plus floor function of x plus y. Okay. Okay, so to prove this, right, we're going to start from here and to see that this is always going to be true. Okay, and so what you do is you let x equal to a plus p. So a is an integer and p is a fraction part. So again, a equal to the integer and p equal to the fractional part. Okay, and same thing, let y equal to b plus q, whereas b equal to integer and q equal to the fractional part of the y. Okay, so now this part, so you start with this over here. And you go and substitute all this in here. So this will be 2a plus 2p plus 2b plus 2q is greater than or equal to, this will be a plus b plus this part over here, the ab part, plus p plus q. Okay. And then from here, the 2a and 2b will cancel out. So you have the 2p plus 2q greater than or equal to p plus q. Okay, and both the p and the q is between 0 and 1, right? Okay, and so this part you're going to get 0 or 1 plus 0 or 1, and this is always going to be greater than 0 or 1. Okay, so this is always going to be true, therefore this is true. Again, if you don't believe that, you can try number. Okay, so just to make it simple, let's say p equal to 0.7, q equal to 0.7. Okay, so in this case, you're going to have the 1.4 plus 1.4 is greater than or equal to 1.4. And therefore, you can see that this is 1 plus 1 is going to be greater than 1, right? See that? So that's when both are greater than 0.5. Now, what happens both are less than 0.5? What happens if you got p equal to 0.3, q equal to 0.3? Well, in this case, you're going to get 0.6 plus 0.6 is greater than or equal to 0.6. Okay, so you're going to get 0 plus 0 is greater than or equal to 0, again, which is always true, right? It's always true. Okay. Now, what happens if you got one of each? You got p equal to 0.7 and q equal to 0.3, for example. Okay. Or in this case, you got floor function of 1.4 plus floor function of 0.6 is greater than or equal to floor function of 1.0. So in this case, you're going to get 1 plus 0 is greater than or equal to 1. Again, it's true. Okay, so you can no matter what, it's always going to be true. Okay, and so again, so that's how you prove that this is always true because of this. This is always true, and you can try any numbers. Okay.